Best greetings again for everyone, dear students, dear math students, and dear students in general. Hoping you are studying, ready for your exams, and hoping you are enjoying so far the way of explaining maths in general. And we are finishing the paper M1. Continuing with the paper, we are in question 4 of M1 October 2024. That says the points A and B lie on the same horizontal road. Figure 2, which is drawn here, is a speed time graph. I will show you now, of a cyclist for his journey from A to B at time 0 from rest for the first 9 seconds, reaching V meter per second. Then he will say, from this, even it's clear, you can read, you can state the question from the graph. Then travels at constant speed V. When T is 42, the cyclist passes B, given that the distance is 120 meters from A to B. Show that V is 3.2. So let's solve the question on the graph is better. So we know for part A, dear students, that the traveled distance, this is well information to you, is area under the graph. Of course, we can do many ways for this, but the fastest and the easiest, we deal with this as trapezium with two bases. This base is 42 and this is 9 here, so this is 42 minus 9, which is 33. So the area under the graph, which is half, times the sum of the bases, which is 42 plus 33 times V, so it's V over 2, is equal to 120. Simple part, this one. So this will give V times 75 is equal to 240. V equals 240 over 75, or divided by 75, which is 3.2 meter per second. Again, I said this a few times, if I'm fast, this easy question, the whole question is easy, this one. But in case, communicate in the comments, I'll be responding to you, dear lovely students, anywhere. Find the acceleration for part B between 0 and 9. So he wants the acceleration here. We just found, dear lovely students, the speed 3.2. So we just divide the speed by the interval of time here. So A is equal to 3.2 divided by 9, which is V over T. Simplifying this or calculating this for the three significant figures, 356 meter per second squared. Easy pass, enjoyable question. Cyclist P continues to cycle along the road in the same direction at the same speed, constant speed. When T is 6, a second cyclist sets off from A and travels in the same direction as B along the same road. She accelerates for T seconds until her speed 3.6 meter per second. Then, or she then travels at constant speed, the same speed. Cyclist Q catches up with B at T 54 seconds. On figure 2, on page 11, sketch a speed time graph showing the journey of both cyclists for the interval of time from 0 to 54. So part C, I will not do there, I will do C here. So I prepared this page for you. So the question said in the first set of 6 seconds later, So from here, it says 6 is here. Then she or the other second cyclist or whatever accelerates until or reaches 3.6, because this is here 3.2. So 3.6 is almost here, above 3.2. Then she kept or they maintained the same speed with constant for 45 seconds, and they will catch up here, he said. So this is the diagram. This is particle P here. This is particle a cyclist P, cyclist Q. This is part C. That's it. Done. Find the value of T. T, where is it again? I will do it in different color to recognize. Is here. She accelerates for T seconds till her speed is 3.6. Labeled directly, dear students. So his T is here. From here to here is T. Of course, well-known information to find T, since P and Q, they're catching up, means they have the same distance. So first step, we calculate the new distance by both. Of course, we have here many alternative ways, but the easiest way, particle B finished his journey with traveling 120 meters, which is until here. This one. So what's the new part till they catch up here? This distance here in blue. So only that will do. The distance now traveled by both or by Q, which is by both since the catches up or the catch up, is 120 meters plus the new part of motion, which is this rectangle here. We know V is 3.2, so this dimension 3.2, and the difference of time is 12 seconds. Which is 3.2 times 12. So the total distance, the distance required is equal to, in the calculator, 120, 38, 158.4 meters. Don't let the calculations, if you have time and you are watching the question, the video, this and like this, calculate during the calculation. Don't delay calculations. Step 2, which is the last step in the question, you write the formula, the equation, which one that you prefer the most to calculate the distance. The easiest way or the shortest way to do illustrating or showing the distance is what? He wants T. So you start first with this triangle here. It's the first part. Let me just make this smaller. This one. Plus this rectangle here. What you'll be getting here, dear students, this is from here to here is 3.6, and the base here is T. So the first triangle area plus the rectangle, the same height, 3.6 times the width, which is what, dear lovely students? This is 54, 6 is gone. So from here to here is 48. And T here will be taken from 48. Getting 48 minus T equals to the distance we calculated here. Simply like this. What's the area of the triangle? Which is t over 2 times 3.6 plus 3.6 times 48 minus 3.6t is equal to 158.4, getting 1.8t plus 172.8 minus 36.t equals 158.4. So this minus t, which is 1 minus 1.8t, this minus this, to be negative 14.4 by dividing by 1.8, you will get 8 seconds. Easy question, dear lovely students. Of course, we must have in every M1, every exam in ES and A level, like a couple of questions, straightforward. Just we have to read the question carefully, then you'll get our steps clearly and less confusing. Stay updated, dear students. Communicate if you have gaps in any concept. I'm here to help you. Best of luck.